let's go through some examples of Venn diagrams. For example, suppose that U, the universal set, the set of everything that we're considering, is the set of these 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. This is a set of numbers. Sets don't have to be just numbers, but this is a set of 8 different numbers. Draw a diagram to represent the following. Set A consists of 3 elements, 2, 3, and 7. So we can label U, the universe, and set A, which is the circle, and let's go through all of the elements in the universe and put them in the appropriate position. This element, element 1, is that in set A? No, so it can go on the outside. What about 2? Is that in set A? Yes, so it can go inside set A. 3 is in set A, 4 is not in set A, 5 is not in set A, and so on. Notice that these numbers, like 5, 6, and 8, they're part of the universe. They're part of all the numbers that we're considering, or all of the elements that we're considering, but they're not part of set A. For our next trick, we want to list the elements of A dash, or A apostrophe. This means the complement of A. It's the set of everything that's not in A. For that to make sense, you have to know what the universe is, the set of all the things you're considering. In this case, let's go through the universe one by one and list the things that are not in A. A good way to see it is that these things here, these elements, that they're in the universe, but they are not in A. So A apostrophe, A complement, is the set of 1, 4, 5, 6, and 8. As another example, I've got 2 sets here, and I'm asked to draw a diagram to represent them, still with the same universe. So because I've got 2 sets, I'm going to draw them as overlapping circles, because there might be parts that are in both sets. I'm going to label U, the universe, B for this set, this circle, and C for this set, which is this circle. And just notice, B is this whole circle. Part of the circle overlaps C, so elements here in C as well, but some elements are only in B. To see how this works, let's go through these elements one by one. 1. Is 1 in B and is 1 in C? 1 is in B, but not C. So it's in the B circle, but not in the C circle. 2 is in the C circle, but not the B circle. So that can go here. 3, is 3 circle in the B circle? Is it in the C circle? Yeah, it's in both circles, so it will go in the middle. 4 is only in the B circle. 5 is in neither circle, so it will go on the outside, and so on. Now, we can list the elements of B. Oh, what's this funny symbol mean? This symbol here, you can see it at the top. This symbol means intersection. So list the elements of B intersection C, the elements that are in both sets. Which numbers are in both B and C? 3 and 6. These are the only elements that are in both sets. Union, the set of elements that are in either set, which elements are in either B or C or both? 1, 4, 3, 6, 2, and 8. You can write your set ordered, but you don't have to. Sets don't have to have a natural order to them. And I hope this has been helpful in learning how to draw diagrams of Venn diagrams.